Okay, it's time to start up. Hopefully, your day is going well. It's an exam day, or it's a day before your exam day. It depends on you when you want to take the test. So I'm here. I can answer questions from the sample exam. I can also tackle questions on pretty much anything you've got going that you think will help you do well on the test. Again, the test released today at 5 p.m. It will be released, if you will. And it's 55 minutes, if I remember correct. I should check that just to be sure. And excuse me, if it's not 55 minutes, I'll be changing it right quick. But my goal was to have it be such that you could take the test and then take up to an extra 5 minutes to, if need be, take a picture, upload a thing like on the last exam. And several of you noticed on the last exam, you did use that piece of paper very productively. It's not a requirement. It's not something I expect of you, but some of you were really happy to write mu and alpha and things which might be otherwise not so easy. And darn it, I have to edit it somewhere else. I'm just trying to check to see what the settings are for the time on the test. Okay, well, I'm going to look at that later. Oh, no, I know how to do it. Haha. And definitely it's set for 55 minutes, so that's perfect. Okay, so it's up to you what we do with our time between now and 5 o'clock, and it's up to you essentially when you want to take the test between now and 11:59 on Friday is the plan. So with that in mind, what do you want to talk about?
I just want clarification for checking the assumptions for the independence. That's just kind of based on the information provided. Like you can't really check residuals for that. Or
Well, yeah, that's a great question. Well, in some cases you can. And here's a situation where you could, if there is a grouping variable, right, that was not included in your analysis, you could plot the residuals against which group it is. And you could get a sense of, oh, group one, the residuals were always positive. Group three, the residuals were always negative. That would formally be a lack of independence. Essentially, we fit the wrong model is one way we could phrase that lack of independence. But if you know the epsilon was positive for Bob and Bob was in group one, and other people in group one are also likely going to have a positive epsilon due to a misspecification of the model, that's a formal lack of independence. So one thing we do is plot our residuals against explanatory variables we could have incorporated into our analysis, but maybe chose not to for some reason.
okay, so if you're plotting like a residual against an explanatory variable and you're seeing like some parts of the data way the residuals are more positive than negative, you would say that could indicate a lack of independence, or would you need more?
If it was an X variable that we had not used in our model, yes, a lack of independence.
Thank you.
I think one of the data sets on the homework is sort of like that, where, and I get maybe it horribly wrong, but we have a negative slope in each of several different groups. But because the groups are sort of stacked up in the right way, the slope, if you fit all of the groups together, as if there was no grouping information, the slope would be positive. And so, yes, we will sometimes see a trend reversal if you don't have important information in your model itself. Good question. Someone else? I think the sample exam questions might be helpful. Let me, because I can, let me go into the sample exam questions, which will maybe help some of you say, oh yeah, I did have a question I wanted to talk about. So I'm going to share a screen. And even if I just talk my way through some of the sample exam questions, you might benefit from that. And please interrupt. But if you don't have a question, and I always want a question, I'm just going to go and start down from the top and note things that I think are interesting, things that you might benefit from hearing right before the exam, and things which might reinforce a concept that we did already hit on, but not every student formalizes it and thoroughly understands everything the first time through. So I'm not hearing a question just yet, but we got some chimpanzees. And in these chimpanzees, in theory, you could teach them words. Some words are easier than others. Because I betcha across words like shoe, look, fruit, yeah, some of those are going to be easier to teach a chimp than others, because I suspect something which is a noun, you can teach American Sign Language to a chimp pretty easily, but a concept like look, yeah, or listen might be a little bit harder to teach to a chimp. Okay, so let's maybe zoom in because I want to be able to read this. And so we fit a model where the time to learn a word depends on the difficulty of the word. Some words are more challenging than others. Got it. Okay, so word itself, which word was it, probably is related to the amount of time to learn the word. But some chimps are probably quicker at learning words than others. I mean, that's just the nature of the chimp. Some of them are going to be good about American Sign Language, others not. I mean, it's probably a foreign language for them in the same way that we all learn foreign languages, but for some of us, it's really quite hard. But for others, you pick it up real quickly. Okay, so there's probably a chimp to chimp effect as well. I could view chimp as a blocking variable if you want to think about it that way. And across the chimps, it looks as though in the effects test, chimp is definitely borderline significant. I would certainly keep a blocking variable in my analysis, even if it were not significant. You're saying there's the possibility of, and we could estimate the effects of the other factors, in this case, word. Each word has a different amount of time to learn the word. We could estimate that having taken into account to chimp differences in chimp learning. So what about the word model? Oh, time equals word plus chimp. Good. Is there any evidence that chimps take different amount of time to learn? Well, with the p-value 0.055, it's nominally above that 0.05 alpha. So I'd say I'm not yet convinced. Notice that I didn't say, no, chimps do not learn differently. I said I'm not yet convinced of a difference. I'm not affirming that the null is true. I'm simply saying that the alternative isn't clearly a better explanation. Let's talk about word, the effect of word on the time to listen. I'm sorry, the word look. So look having a 141.95, let's call it 142. I would say the word look takes 142, and I'm measuring, I guess, y with units of like minutes to learn the word, okay? So it takes a chimp on average 142 minutes more time to learn the American Sign Language for look than the average across these 5 words, okay? The average across the 5 words. Okay. What about that sum to zero parameterization versus a reference group parameter? Oh, question first.
Is there any way you could just repeat what you just said about C?
Yeah.
Thank you.
I would say that now let's get into the interpretation of more than just one of these parameters. But if we have y as the amount of time in minutes, and I'm presuming minutes here, but if you if you chose different assume amounts of time, that's fine. I'm going to say minutes. And so looking through these parameters, I would say the average amount of time to learn a word across these 1, 2, 3, 4, 5 words, the average amount of time to learn one of the 5 words is 91.55 minutes. And that's averaging over the 4 chimps. So the average across all the treatment conditions is effectively what our intercept is estimating for us. And so let's talk about then the effect of the word look. 142. It says the average amount of time to learn the word look is 142 minutes more than the average amount of time to learn a word. Look's a difficult word to find to learn the ASL for if you're a chimpanzee. So does that get to your interpretation question, Kendall?
Yeah, thank you.
Okay, so moving on a little bit. Sum to 0, would that be good? Is there a natural reference group here? What would be the better parameterization? Sum to 0 is the default for a reason. That's what people tend to do unless there is a natural reference. And I don't know what the reference word ought to be. But if you tell me what the reference word is, and maybe you go with listen as your reference word, or maybe it's fruit. I mean, I don't know, but I'm saying if you tell me that there is a natural reference word, then I'm thinking, then I would go with the reference group or indicator variable parameterization. So if someone makes the argument, indeed, and they say, oh, yeah, well, of course, the word more is going to be the natural reference. And so let's compare the amount of time to learn the other words compared to more. Okay, so is this graph good, bad, or ugly? Good, bad, ugly. I would say it's closer to the ugly category than the good category or the bad category. My reason for saying is ugly is it looks as though certainly for a predicted amount of time that's like negative, the residuals, of course, have to be positive. For predicting negative time to learn a word, there's something goofy going on, first off, but I see what looks like this little stripe. That's a stripe that corresponds to it took longer to learn the word than you would have thought. And I'm seeing not just this funnel shapedness, it also looks somewhat curved here as well. Now, if I were using the lab from last time carefully, you see funnel shapeness, you see nonlinearity, and if you see both of those, perhaps a transformation of y will be helpful. Now, I'm not saying this because I expect you're going to do this on the test, but if you want to know about the sort of transformations of y that would be likely good, they're in the category variance stabilizing transformations. Square roots and logs are what we tend to use right off the bat, because there's often physical, biological, theory-based reasons for why a square root or a log or a cube root would make sense in some contexts. But I'm thinking it also tends to take variances that are much wider for high predicted times. Like we see a lot more spread vertically here for the predicted time being high than when the spread is, I guess predicted time is lower, the spread is less. A variance stabilizing transformation like a root or log would be a good way to go. I would probably actually take a log and probably go with the log base 10, because it doesn't matter if you do log base E, natural log, or log base 10. And in the context of something we measure in minutes, log base 10 is a little bit quicker to grok to make sense of than if I go with natural log. Usually I use natural logs unless it's a context where I think, oh, minutes, yeah, of course. 100 minutes, that's a natural log of exactly 2. I mean, log base 10 of 2. So I'm thinking that's a bit of a problem here. And I would say a transformation of y would be a good idea. Now, how did students answer this question? If they spotted the curvature and if they spotted the funnel shape, that's good. And did I require them to say, oh yeah, take a log of y? I didn't. But maybe the students sort of knew that a root or a log would be a better fitting model than the actual predicted times or the times themselves. Any questions about that so far? Question 1. Chimps. Okay, I want to mention one other thing about this exam, or not exam, but this question. Notice that there's 19 degrees of freedom in total. That means there's 20 data points. And we have 1, 2, 3, 4, words shown here. So that means there's 5 words. The regular parameter estimates always give us the number of groups minus 1. So there's 5 words and there's 1, 2, 3, 4 chimps. You could also see down here, if there's 4 degrees of freedom for word, then you've got 5 words, and then 3 degrees of freedom for chimp. That means there's 20 separate 4 times 5, 20 separate word chimp combinations, and we've got 1 of each. This is a balanced design. If we were to look at the sequential tests instead of these effects tests, the results would be identical. Yay. Okay. 2 other things to mention. Oh, do you think it's possible that some chimps have more difficulty learning certain words than other chimps do? I'm betting so. That would be an interaction. Can you estimate an interaction? Not so easily, because once Bowie has learned the word look, you can't reteach Bowie the word look again. So we can suspect that there might be an interaction, but we can't tell if there was one for sure, because we can never collect the data that would allow us to look for that. Look, that was funny. Because Bowie was looking. I found it funny. Fine. Okay. Here's the data set that was in an economics journal a while ago, a long time ago. And the reason is we were concerned with whether countries are going to deforest their forests quite differently based on their population or the amount of debt the country has. So we fit 2 models on the left and on the right, and the population shown here, or there, if we're looking at the regression coefficients, debt and then constant, yeah. This will tell us the deforestation rate is a function of just the debt and then the population numbers. This second model here has, debt, population, and then an interaction between debt and population. So conceptually, for people who are into ecology or economics or forestry, they might know quickly the answer. Well, of course, a country that's in financial need might say, well, we can sell the wood in the forest that we have. Whether it's for turning into charcoal or whether it's making into boards or homes or whatever it is, the country owns, in theory, some of the forest. They can sell it off and use that wood. So the forest will disappear. Or shoot, what if we're talking debt of the country as a whole, and that would include personal debt? If you own a large swath of forest, and the word swath only appears in that context of a forest. If you own a large swath of forest land and you're in debt, maybe you could sell, 30% of it and pay off your debt entirely. Would that be a good move financially? Maybe. And so debt could be related to the rate of deforestation. What about the population of a country? Well, more people, there's greater need for wood. More people, there's greater demand, if you will. So population of the country should be taken into account when looking for a debt deforestation rate. So you need at least to have population here. And this variable being highly significant, population being highly significant, says it shouts out, indeed, you need population in the model before exploring a debt relationship to deforestation rates. B. Hey, what about an interaction between debt and the population? I'm sorry. What would an interaction between debt and population do to the relationship between debt and deforestation? That interaction, it says the effect of one variable on the response depends on the other variable. The relationship between debt and deforestation is different in the highly populated countries than in the countries with a lower population. That's the way I choose to phrase it. You could also phrase it for full credit by saying, oh, the relationship between population and deforestation is different if the country's debt is high than if the country's debt is low. That's a little bit more awkward from an economic or ecological point of view, but it's technically correct. Which model is better, the interaction model or the model without? You tell me in C. I gave full credit to an answer of the p-value for the interaction says we don't see a need for the model with the interaction. The interaction is not proving itself necessary. And so maybe that would be a reason to prefer the model without the interaction.
For that problem, in
Yeah.
your answer key, you talked about the adjusted R squared being higher.
Yeah, I don't like adjust R square. I've changed
Okay.
my mind. Don't use it ever.
Thank you.
Now, next week, when we talk about variable selection, I will say that a competitor to adjusted R square, this number that we call AIC, maybe it would be suggesting the second model over the first one. But no, please don't use adjust R square for comparing models. There is a better way, a better path, if you will. Okay. But you're right. If someone had said, oh, look, adjust R square is higher, that's a better model. You know, I'm cool with them saying that. I just would prefer them in the future to not use adjusted R square as the criterion for choosing models when there is a direct hypothesis test. Okay. Oh my gosh, lots of words. Using the model with the interaction, would the relationship between debt and deforestation be steeper in a low population or a high population country? Consider the country of a 3,000 or versus 30,000, 3,000 or 30,000, 3 million or 30 million folks. So if we're talking a population times the slope, that itself doesn't change the steepness of the curve, right? Plugging in a 3,000 here or a 30,000 here would not really change the slope of debt, would it? No, not at all. It's just going to change that intercept. But if I take debt and multiply by 3,000 times this number here, that's going to be then added into the slope for debt. Or if I took a population of 30,000, it'd be debt times, well, 30,000 times that point, lots of zeros, then followed by 1. Then it's a larger number that would be added to debt here to be an adjustment to the slope. And so you could math it out, okay? Steeper is a word I'm trying to avoid nowadays because of this question or questions like this. Rather than steeper or shallower, I like to say more positive than it is, or less positive than it is, or more greatly negative than the current slope, or, et cetera. Which slope is steeper? If you had this as a data set in front of you, and if I use the data set to create a question, I'll make that data set available to you. You could try that regression model with the interaction, and you could try that profiler like we did just recently, and you could drag the population from low to high. Or if you wanted to just do the math, you could say, again, I'm going to write down the trend line for a 3,000 value for population, calculate the new intercept and slope, and say, well, what if the population were 30,000? Again, I could do that work and calculate the new intercept and slope, and I'm all good. Okay. Any questions about D?
Can you explain the why for the steeper slope for like when you do it for depth population interaction?
Well, okay, so I'm avoiding the words steeper versus shallower, because indeed some folks would rather use I shouldn't say rather. Some people will interpret a negative 0.9 slope as steeper than a positive 0.8 slope, because 0.9 is a greater value than 0.8. Yeah. And so there is that confusion. So I'm trying to avoid the use of the word steeper. I'm saying if we plugged in two different values, say 30,000 versus a sort of 3,000 or 30,000 into this value for population, this interaction, and shoot, let's just go with, move it over one. Okay, I can't read this so well. I'm going to zoom in. No, I can't zoom in. Okay, I'm going to lean in. 1, 2, 3, 4, 5, 6. If I slide it over 6 units, it's going to be adjusting the slope by 1. And this only slides over 1, 2, 3 units, 1, 2, 3. You're going to add a 0.0003 to that number there. It's going to be negative still. Versus if I had a 30,000, you're going to be adding in 0.003, a slightly larger number. And eventually one of them will be steeper than the other, but no, one of them will be more negative than the other, or one will be more positive than the other. Cami, does that get to your question?
Yes.
Okay. Okay. Whew. Okay, so here's the question that I like because it's a hypothetical and it ties to one of the things that we had looked at earlier. One of the questions we looked at earlier, but it was about the residuals in that context of that question. What if I had information about which countries were tropical and non-tropical? I mean, literally Brazil well, I'll go with Brazil because there's a lot of jungle in Brazil, and the trees grow quite quickly there as opposed to in Chile, because Chile is on the western side and it's a lot drier and trees grow more slowly. So tropical trees grow more quickly, non-tropical grow much more slowly. How could we adjust our model to allow for that? What sort of word model would I want to have? Well, let's think. Tropical and non-tropical countries behaving differently in terms of how they harvest lumber. So at least a tropical, non-tropical variable should be added into the model, a categorical variable. Some folks would say also add in a tropical, non-tropical categorical variable times debt as well. Because it's probably fair to say, and this is more economic wonkery, but if you have a resource that takes a long time to regrow, you're going to have a different sort of relationship between debt and harvesting that resource than if you can regrow it rather quickly. So yes, if I'm cutting down tropical forests, then just in 5 years, I can cut them down again. But if you cut down old growth oaks in Chile, you're not going to get them back in your lifetime in such a way that they could be harvested. So this deforestation rate, maybe it would be different between the two countries, but also debt, the relationship to deforestation also legitimately could be an interaction. So some students added that in because they're sort of like econ oriented. And certainly there was 3 years ago, a couple of students, one from Chile and one from Argentina in the same class. And they were commenting on exactly this issue as, there's no way that we would cut down trees in Chile for debt. And the Argentinian is like, why? Why would you not do that? We have they will go back. And the person from Chile is like, you just can't because they won't grow back quickly. Okay.
So just to clarify, if on the test we put an interaction with like the tropical variable and the debt, would you accept that, or should it always be the tropical interaction with the population?
Oh, I had supposedly the tropical, non-tropical countries would possibly behave differently in terms of how they harvest lumber. Supposedly, okay, so tropical times population, which I do believe I had in the answer, was trying to capture the feeling here of tropical and non-tropical are different. Tropical times population, you could put that in there because if you have a huge population, you have much more of a need for wood than if you have a smaller population. And so tropical interaction with population or tropical interaction with debt. I was happy with both answers. And I think the one in the answer key says tropical population. But what I just what I just spun for you, what's the past tense of spin? What I just told you was, debt in tropical would be what I'm thinking of now. But that's based on chatting with those students that one term. Okay. Okay, yes. This is a great question. In a lot of ways, and we'll tie it to a lab next week. Okay. And so I don't want to sort of like steal from you the opportunity of experiencing some joy on the lab, but if we were to show you some analyses, oh, hold on, what happened? Oh, there we go. If I were to show you analyses, then, and analysis B is the analysis, okay? We've got the model that we fit in terms of parameters. There's like 2 different types, cooled and fresh, 2 different treatments, control and this chemical called PAF, the amount of time since the horse semen was obtained until we're measuring the motility or swimminess, if you will, of the semen. And then there's this interaction and shoot, you're thinking try minus 60. I don't want to deal with time minus 60. If you deselect the center polynomials, it's going to allow you to sort of avoid that problem there. Okay. But this is what you were given. And we're looking at those data and is it balanced or not? Well, I'm going to say if you have a model without interaction, looking for balance there is going to be pretty easy and straightforward. So are the effects test, the adjusted sum squares equal to the sequential sums of squares? Well, I see all 3 of them are, and so yes, it's balanced. Actually, hold on, is it balanced? No, I know it's at least orthogonal. It's at least orthogonal. If you looked at the data set, you can determine balance. And so I probably would have rewritten this. Is this design orthogonal if I was doing it at this term? Okay. Because yeah, sequential and adjusted sums of squares are the same, therefore orthogonal. Just a quick comment on orthogonal versus balanced. Balanced means the exact same number of data points per treatment combination. And so for each of the treatment combinations, the same number of data points. Orthogonality could be done a little bit differently. So as an example, we might have a population, and in the population, there's two distinct ethnic groups. And you have 80% of one group, let's call it the majority group, and 20% of the other group, called it the minority group. And if you have a treatment, and not just one treatment, but three, there's control, and there's the current way of treating people, aspirin, and then there's the new way of treating people, aspirin plus a beta blocker. We would want to maybe have not exactly balanced, but we know that aspirin, by the way, is definitely better than no treatment at all. So let's go with a not so big of a control group, but let's have the 2 aspirins for every control and 2 beta blockers for every control. It's always a 2 to 2 to 1 ratio for beta blocker, aspirin, control, 2 to 2 to 1. And it's always going to be in each of the ethnicities, or the ethnicity would be 80-20 in each of the aspirin groups. That would be orthogonal, but not balanced. Okay. And as long as we have the same ratio across the treatment possibilities for each of the blocking groups, you've got orthogonality. Okay. So relative to the control group, how much higher is the mortality with this chemical PAF? Let's look at PAF, the effect. Well, I got the control group over here. I got the control negative 4.375. So compared to the control group, does PAF help? How much higher is the motility with PAF than with that control? Well, the control is to, it takes the motility down by, let's say, call it 4 units compared to the average motility across both treatments. So I guess the effect of PAF is to increase by 4 units, twice the estimate of being in the one group is going to give you the difference between the 2 groups. If you are using a sum to zero parameterization and you say that on average, males are an inch taller than average across both sexes, you think, oh, well, females must be an inch shorter than the average height across both sexes. So me telling you males are an inch higher means females are an inch lower. And if we're comparing males to females directly, it's a 2-inch difference. So twice then, the effect of one of the 2 levels will give you the difference of the 2 levels. So if you want to go with a reference group parameterization, if control is your reference group, PAF is twice 4.375 higher than the control. Okay. Okay, so up here. Why would you want to control? Why would you want to control for type fresh versus cooled? If you're really caring about the effect of this PAF, why would you want to try fresh versus cooled? And fresh is literally refrigerated, and cooled means frozen. Those are the 2 ways horse semen is delivered to people who buy it. And we would like our chemical to be something that we could evaluate in each of the 2 conditions. Maybe as a chemical goes for increasing motility over time, maybe it will work great for fresh, but not for frozen. Maybe it's the other way around. We have to literally find out by running it. Okay, so you have to sort of block on that variable if you'd like to see how things do in both of the ways of treating it. Okay, estimate the motility of, if I tell you fresh PAF 75, you're thinking, how could I do that? How could I do that? Well, I have a slope for time. You could plug in a 75 times the time slope. I could plug in PAF. Well, that's a positive 4.375, and fresh is a positive 10.29, and you add that all to the intercept. Questions about that? Okay. What about analysis B and analysis A on this next page? We include an interaction in analysis B. Is the interaction statistically significant? I would say it is, yes, barely so. 0.04 is less than 0.05. What would an interaction do for us? Well, if the interaction is between tree, I guess, type and time, that says that perhaps the motility decreases quicker for fresh than for cooled. Now, I don't actually know what the data say. I don't remember anymore, but it seems reasonable to me that if you freeze it, the swimminess is going to drop down a lot from the freezing and then rethawing. If it's fresh, initially it'll start higher, but over time, it's going to decrease the motility, maybe more quickly than frozen. I don't know. We'll find out. I mean, it's going to be one or the other. It's steeper or shallower in one of the two groups, but that would be the interaction. And, which one is a steeper decrease? Well, you can tell that sometimes from just the sign of the interaction. If it is cooled, the slope of time is 0.07 steeper than the 0.15 negative. So cooled is about a 0.08 that's negative. Fresh is about a 0.15 minus 0.07. So that's like a negative 0.22. So yeah, decreases quicker in the fresh group, much quicker. Okay, so how do you know? Well, I did the math. You could say I did the math in my head, or you could better yet do the math yourself, or maybe just note that because the adjustment, okay, there is a slope of time. For the cool group, the adjustment is to make it 0.07 higher than what it was. That's going to be closer to zero. The fresh adjustment to the interaction, or the fresh interaction adjustment to the slope of time, is to decrease it by 0.07 from the negative 0.15. So yeah, you could do the math, or you could argue from just this number here and it being associated with cooled. Interaction between type allows a clearer picture of the average relationship. So average relationship between time and motility. Do I see that time has a lower p-value now than time had earlier? Yeah. Because there's two different slopes. What had formerly been a washed out ability to spot, in general, there is a decrease over time. We're now able to say, oh yeah, clearly there's a decrease over time on average. And in this group, it's steeper. And in that other group, it's less steep. So the p-value of time is lower than what it used to be. Cleaner picture. Finally, R squared in the analysis of this context. Okay, I can explain 58% of the variability in semen motility in horses, semen that have been harvested for sale, based on knowing whether it's fresh or cooled, treatment or control, and the amount of time since the harvest of the semen. Okay. I think that's all the questions, or was it? Yeah, that was it. Hey, any questions about the questions? Okay, I want to mention one thing, and this is because I believe Anthony asked it yesterday, but I'm not sure if he asked it while you were all in class, but he asked about, oh, look, on the partial F test, we didn't see anything like that on the sample exam. And yeah, you're right, you didn't. Does that mean you won't have it on the test? No. What it means is there isn't an example of a partial F test on the sample exam. And if you think we covered it and you think it's reasonable to put on a test, you might want to review how to do it before you take the exam itself. If you take that as a hint, fine. If you take that as you being chided and told you should study this, I don't care. It's something that you should know, certainly for the final. And so if you prep for it now, as though it could be on the exam now, it'll save you time from later. So take that for what it's worth. Any other questions? Well, I noticed that last time, I believe 2 of you started right at 5 or like 5:10, right after class ended on Thursday. That's fine. Go for it if you want to. Others of you waited until the last possible minute to start. Literally, you know, if it's a 55-minute test and you started at 11 p.m., well, you know, you should be finished by midnight. But as one of you found out during the course of the exam last time, the internet will sometimes suck and go down, and you won't be able to answer the questions necessarily. Let me know if something like that happens. We can work it out. I would rather you do that in a reasonable way at a reasonable time than sort of like, well, the internet went dead at 11:53 and I couldn't finish the last 7 minutes of my test. You know, I don't know the best solution to that, but I can give appropriate amounts of extra time based on what you're telling me and what I can read in the test so far. You know, I can sort of read a log of what you've done when answering various questions. Just let me know if you need me to adjust something because of some unique feature. But to avoid stress, don't probably start at the last minute is what I'm saying. One student in a past term who did that start at the last minute and had their internet go down for, you know, let's just say 8 hours. They were really stressed when they did send that email the next morning, because it took until the next morning until the email could go out. Don't be that stressed person. Let me know. It's no big deal. Okay, last call for questions of any sort.
I had
Okay,
a question on one of the
Oh, please.
homework.
Yeah, Diana, what?
It was homework 3A. For one of the answers, we had kind of like a quadrant graph, and I was just wondering how to interpret that. I can share my screen if it makes it any
Yeah,
clearer.
let me make the screen sharing something that you can do. Okay, so adjust. There we go, and stop the share. And you can now share your screen,
Okay.
which might allow me to answer more cleanly and clearly.
Yeah, it was just one of these graphs. Can you see my screen?
Yes, I can.
Yeah, I was just wondering how to interpret that with all the labels.
Okay.
It gets confusing.
Yeah, so I love the question, and if this is one of those that you email me about, I should probably mention to all of you, I'm about a full day behind on answering emails. And second, and maybe more importantly, if you email me about a lab and your grade on the lab, or you know something else that's not urgent, I'm going to put in that lower priority queue compared to people who have emails about subject matter things and want it right quick. And so if I missed something, I'm sorry, but let's tackle it right now. And can you make it just a little bit larger with a, hey, that was slick. Okay, so I'm seeing here, and I'm going to go with the upper right. Yeah. I see yes and no. And that's antibiotic, blue. Yes, you got the antibiotic. And you can see down at the bottom of the right-hand column, you see B12 no and B12 yes. So if we're at the blue left side down low, that is yes antibiotic, no B12. Yes antibiotic and yes B12 is at the other end of that blue yes line.
Mhm.
Yay. I appreciate that you signaled exactly the way I wanted you to. And so here I would say, if you are not on the antibiotic, that no line, the red one, it doesn't really seem to matter whether you have B12 or not in your diet. It's just, there's no benefit of having B12. I don't see any benefit at all. But if you do have the antibiotic going on, you're in the yes line, the yes group, certainly B12 is really beneficial in terms of weight gain. Now that's from that upper right square. That same thing is found in the lower left square as well, but let's now go there for the interpretation. The yes in this quadrant is yes to B12, and the no is the no to B12 in the lower left quadrant. And so we can see if you are looking at the yes and no lines on the left where it's antibiotic no, there's hardly a difference there at all. No antibiotic, well, B12 or not, yes or no, doesn't make a difference. But if you do have the antibiotic, if the antibiotic is in the yes, you're on the right side of that graph. Oh, yes to B12, huge benefit in terms of weight gain. So Diana, does that get to the question that you had?
Yes, thank you.
Yeah. The other thing I would encourage you to do, if you fit a model where an interaction graph could be utilized, you can also just use the factor profiler. And so that, because you can drag things around and look between the cases, you might see something more quickly with the profiler than with this static graph. Some of you know, oh, look, I used the profiler and I was happy with it. Just during a test, go with the profiler first if you know that's going to be more helpful. The interaction graph here is fine for me if it's static, but some of you know you prefer the profiler, so use that instead.
Okay, thank you.
Okay, yeah. Any other questions on that one? Okay, any other questions at all before I stop the recording? Okay, so yeah, enjoy your test. Who enjoys tests? I don't. I don't like writing them. I don't like grading them. Every so often I think, oh, that was a really good question. But other than that, it's not fun to prepare them for you, and it's not fun to be in your shoes and take them. But to the extent possible, don't worry about the test. Do your best. Prep for longer if you need to before you take it, and just do as well as you can. And don't worry, everything's always good in the long run, right? Cool. Okay, so due by Friday at midnight, unless there's a specific reason that I've already talked to you about or that you can let me know about. Otherwise, enjoy your test and we'll see you in the future.